Greetings to all the faculty members. Myself Amitabh Das, and I am here to present my project presentation on real-time drowsiness detection system. And I, with the help of my team members Aditya Singh and Ashutosh Goyal, have done the project under the supervision of Ms. Aishwarya Gupta. So this is about real-time drowsiness detection system, and this presentation would be consisting of the introduction of the project, the status summary, the current project status with our addition to the project, and we'll move on to the coding, implementation, and execution part of the project after that. So what is actually the scenario in our project? So we are intended to develop a real-time drowsiness detection system. So what actually is driver fatigue or driver drowsiness? It is that sometimes due to long working and due to long driving hours, drivers do not get proper rest. And that is why they feel sudden dizziness or sudden drowsiness due to which accidents are intended to happen. And these accidents are more or less caused by the tiredness, the state of tiredness of drivers. And these are more likely to happen on the long journeys on monotonous roads such as motorways between 2 p.m. and 4 p.m., especially after eating or taking any alcoholic drink between the sudden time ranges of 2 a.m. to 6 a.m. after having a less sleep than normal after drinking alcohol. If the driver takes medicines or something like that, these causes drowsiness and after long working hours or on journeys home after long shifts, especially night shifts. This work is intended to develop a non-intrusive system which can detect driver fatigue and issue a timely warning. Our project mainly consists of three modules, that is the webcam video capturing, which will continuously monitor the video feed of the face of driver by getting located at the steering wheel. The second one is the face and eye detection, in which we will go on to develop a facial coordinate landmark system on the basis of captured face, and the final module will be drowsiness detection with alert message and alarm sound. So the current status of the project is that we have completed webcam video capturing, the facial eye detection, and eye aspect ratio calculation, which is the main formula, and the facial landmark localization and detection. The status of our research paper is that it has been completed and has been reviewed successfully by Ms. Aishwarya Gupta and is in publication at IJITEE Bhopal. And it is intended to get published in the next issue, which will be next month. So what is our first module? Our first module is that the continuously monitoring of driver face is done through the webcam video capturing, and the camera appears and the image shows the detection. This is how the facial coordinates are meant to be developed on the basis of the algorithm we are using. After the facial coordinate has been developed, we move on to second module, that is the face and eye detection. Test image which will be uncaptured, that is the webcam feed, and then it shows the image showing detection. This is a visual demonstration of how things are going to appear when the driver is driving and the webcam is continuously monitored. The first image shows that the eyes of the driver are in closed position. The second one shows that it is in open position. The third image is a localized graph that shows coordinates of the eyes, and on the basis of which it develops the algorithm. And the fourth image shows the alert which it will issue, that is the timely warning, on the basis of a threshold value that we have set. We move on to the formula of eye aspect ratio calculation, that is uh, P1 to P6. Those are 2D coordinates of eye positions. So this is how the formula can calculate the drowsiness detection level. Firstly, the image is selected and the detector runs the algorithm. After that, the webcam captures the user's image and detects the eye in the face region, and the captured image is passed on to landmark localization, and the eye aspect ratio is started to show the output result. Our addition to the project is that real-time detection is done. Ours is a non-intrusive approach, so we have implemented the eye aspect ratio and the facial landmark localization, which detects the actual positioning of the database, and it usually avoids the use of a complementary database. Ours is more accurate system, where we have tried to improve the accuracy of detector by using eye aspect ratio and the facial landmark localization, which integrates the eye aspect ratio and hence improves the accuracy by up to 30%. Ours is also more cost effective and reliable as we have developed and implemented the whole application in our commercial laptop and prototyping, hence reducing to the work cost to almost zero. So this is all about what is the project, and now we'll move on with the implementation phase. So stay tuned. Thank you.
So this is the OpenCV tutorial and Python script, and I am giving the demonstration of drowsiness detection system using OpenCV and daylib library. So we are going to detect the drowsiness in the real time and also give the alert to the user so that if he or she is falling asleep. So this is the code, and as usual we have used daylib based library to detect the face and facial landmarks, and this is the way to detect the eyes. So that is the predictor path where the trained predictor is located. That is the left eye and the right eye. When we detect the drowsiness, we start a thread. So we have used the daemon thread. The best property of a daemon thread is that it is independent of the system, and that's why we have used this thread, is because the threads does not affect the execution of a program. Threads are independent process and get terminated independently. So I am going to run the script. So you can see here on the screen that eyes are open. The caption is here and this is the alarm. So there is a okay. The first three alarms rang because my camera is not aligned to my eyes, and there is a slight problem that is occurring with the alarm right now, but we are trying to fix it. So we will test it again, and in this case the camera should be in front of our eyes, and as we can see that there are facial landmarks, and these 6 points describe the coordinates of eyes. So when I close my eyes, the caption shows that eyes are closed, and so I kept my eyes closed for a time, and again the alarm sounds. So eyes are closed for a particular time, and it gives the alert by using the thread. So once again it detects the state. The algorithm is not that much good, but we are working on it. So we will test it again, and the camera should be in front of our eyes. So the algorithm that we have used is the aspect ratio algorithm, and we will use it with the aligning of eyes. The best property example is the daemon thread, and our algorithm is almost 80% accurate. So this is how the scripting is done in OpenCV Python with the help of dlib library. And so this is how the script goes on. So yes, thank you.